Okay, so this is question 5, and we've got f of x map into 2 plus log to the base 4 of x, and x is a member of the set of real numbers, but x is greater than 0 because we can't take the log of anything less than or equal to 0. So first of all is evaluate this composite function f of 1, solve the equation f of x equals 0, and then find the inverse function. So let's have a go at that. So part A, so we've got f of x is equal to 2 plus log to the base 4 of x, and we're after f of x. So wherever we see an x in this equation, we're going to replace it with f of x, so we get 2 plus log to the base 4 of f of x, and f of x is all of this, so we get now 2 plus log to the base 4 of x. Okay, now there's nothing we can do here. We can't simplify this down in any useful or meaningful way. So we're now asked to find f of 1, which is now 2 plus log to the base 4 of 2 plus log to the base 4 of 1. Log to the base 4 of 1, log to the base 4 of 1 is 0, log of anything is 0. So now left with 2 plus log to the base 4 of 2, and log to the base 4 of 2 is a half, because half is what I raised 4 to get 2. So I've got 2 plus 1 half, which is 2 is 4 over 2, so that becomes 5 divided by 2. Okay, now the next part of the question was to solve the equation f of x equals 0. And in part B, we're just going to equate this to 0, so we get 2 plus log to the base 4 of x equals 0. So we take the 2 across, so log to the base 4 of x equals minus 2, and we raise both sides to the equation to 4, so x equals 4 to the minus 2, which is 1 over 4 squared, which is 1 over 16, so x is 1 over 16. And in part C, find the inverse function of f to the minus 1 of x. So in part C, we know that f of x equals 2 plus log to the base 4 of x. And when we're finding the inverse function, we put f of x equals y to make the algebra easier for ourselves. And we're going to make x now the subject of the formula. So we now get y minus 2 equals log to the base 4 of x, and we raise both sides to 4, so we get now 4 to the power of y minus 2 is equal to x. We now do the variable interchange, and with the variable interchange we basically swap the domains and the ranges round. So the y becomes x and the x becomes y. So what was a domain becomes a range, and what was a range becomes a domain. And so finally we can say that f to the minus 1 of x is equal to 4 times x, or 4 to the power of x minus 2. Okay, and we can always check this. This is the end of the question, but as a quick check, we know that f to the minus 1 of f of x should be equal to x, and so here we can say 4 to the power of x minus 2, and this is a composite function now, so wherever we see an x, replace it with f of x, which was 2 plus log to the base 4 of x, and then we're subtracting the 2 here, so the 2 minus 2 disappear, so we've got now 4 log base 4 of x, and that now just becomes x. So the check has worked.